You start with the biggest numbers first and you go down. So in one form of nuclear isotope 40, you get one neutron rather, in this shell, 4 neutrons in that shell, and 3 protons in that shell. In another form, by computation, you get no particles in the first shell, 5 neutrons in the second shell, and 3 protons in the second shell. That gives it very different properties. In fact, the energetics are different, and the half-lives are very different. The first form of potassium-40 has a calculated half-life of about 1.3 billion years. It's also the one that they quote experimentally, so it agrees. This new form, potassium-2, is 3.18 weeks. That's another form of potassium-40 that's never been measured. Why? Because it would have all been destroyed when it was created. It decays much too fast. There's none of that would have been left. You'd have to have a fresh isotope of potassium-40. Here's how potassium-40 decays. It decays to calcium-40 and a beta. That's the 1.3 billion year half-life. Also to argon. There are 2 ways you can look at it: as beta absorption or positron emission. Same thing, okay? 1.3 billion year half-life. There's much more of this happening, about 80% more of that than that, okay? The second form strictly goes to calcium, 1.65 weeks for a half-life. Very fast decay, see? We calculated that using the model, okay? Here's some other nuclei, just to show you that it works. Beryllium, potassium, thorium, all of these guys. These are the calculated numbers, okay? These are the reported numbers in the literature. They all agree almost perfectly. If you can't read these numbers here and these numbers here, if you want to look at them up close, you're welcome to do so. But I'm sorry that this is such a gray slide. It was originally done that way, and all we did was, scan it into here. But these calculated numbers using the Berkman-Lucas model agree perfectly well with the known numbers that are in the literature. What are we saying? We're saying you can use the Berkman-Lucas model to do accurate nuclear calculations, and we have done it, and it works extremely well. Now, who wants to believe it? I don't care. I mean, the results are there, If you want to use our equations in our program and calculate those numbers, you'd have to go to Eric. He's my associate. He's the one that wrote the program and did it, but you could do it just as easily as we could. So bottom line, end of story. Have radioactive decay rates changed over time? Definitely. When did they change? At the time of their creation. They change within matters of minutes. Extremely fast changes. What do they measure now in the present time frame of the Earth? Billions of years in the half-lives. That's what they measure. That's not the same condition as they were exposed to initially. And then the end of this was, does the Berkman-Lucas model have any validity, even though it's severely criticized? Yes, it does have validity. I was one of the major critics in the beginning. I talked with, Dave Bergman and Charles Lucas at length, and I told them I was a quantum mechanic theoretician, which I am. I'm a quantum chemist, basically. I do electronic structure and bonding calculations. That's my field. I don't always do nuclear physics, but I do nuclear physics sometimes. And I told them, I said, I don't believe it. I said, well, give us a chance. We'll set up a model. We'll do the calculations, and we'll let you know what happens. That's the results right here. They worked. I mean, they worked beautifully. So we can't criticize it anymore. It's a valid model. In fact, if you look at some of their papers from Common Sense Science, you will see the properties of the protons and the electrons and the neutrons. They're all, detailed for you, and they're excellent agreement with the accepted values, every single one of them. So we have validated the Berkman-Lucas model as applied to nuclear properties, and we think we have validated that there has been accelerated radioactive decay, so that all the decay measurements that are being done now are worthless. You just as well quit doing them. They have no meaning whatever. And I'll stand on that. Thank you.
Question to summarize to make sure I'm following, because this was technical and it was beyond my ability to follow all those calculations. So what you're proposing is at some point in the, and when, I'm not exactly clear when in the creation account, but
Okay.
at some point in the creation of the Earth, it was in a plasmoid state, and